So now let's just look at the scoring on this. There's nothing too astounding about it. The point values are 2, 2, 3, and 2. It's as we expected, since part 3 had a lot more work to it. I don't know, this is part 2. 2 was hard to figure out, but it's not a whole lot of points because there's not a lot to do once you do figure it out. So in part A, all you get is the integral and the answer. So remember, as long as you write this or this, either one, right? That's all they wrote. They didn't write. Oh, I noticed that I left my limits off. So we have to have the limits on. So an interesting question is, since I got the answer right, would they give me the integral point even though I forgot to write the limits on? I could hope so, because I couldn't have gotten the correct answer without having the correct limits. So it's sort of implied that I have the correct limits. But of course, to be careful, we should make sure we have these limits on there. So that was 1 point for the integral, 1 point for the answer. Then for part B, you have... again, 1 point for the integral and 1 point for the answer. This time I remember to put the limits on, and there's my integral and there's my answer. That's all you have to do. You don't have to write out what the function is. They wrote out the sentence, the average distance from the origin point on the curve is blah. I don't think we need to do that. I don't think we need to say the area of S is 3.534, since we gave the answer of 3.534. Certainly couldn't hurt to do that. Maybe write that, your answer as a complete sentence is not a bad idea. I didn't do it though. Part C, you get equates polar areas. So that, I think, just means really we're saying... I'm not sure what part of this is equates polar areas. I guess they mean this area and this area, which also is the same as saying this area and this area. So we've equated polar areas. That one's a little vague. Inverse trigonometric function applied to M as limit of integration. So we have our inverse trigonometric function of M as limit of integration. We have it twice in our formulation. They have it only once in their formulation, because remember, they're using area 1 is equal to 1/2 of the total area instead of we did A1 equals A2. They're both legitimate solutions. I personally think that since I used the inverse trigonometric function applied to M as limit of integration twice, I should get 2 points. But they're probably not going to give me that. And then the third point is for the equation. So I guess that means just the total equation. So we get 3 points for that. And then our last part, our points are for limits of integration. So as long as I get the 0 and the pi over 2, as long as I get that what they were really asking me to do is an integral from 0 to pi over 2, then I'm going to get that point for limit of integration. That's the totally wrong solution, though. Here we go. Limits of integration are here, 0 to pi over 2. All right. So I get 1 point for the limits of integration. And the other point is answer with integral. It's a little odd way to say answer with integral. So that's an unusual grouping. They want the integral and the answer is 1 point, and then the limits are the other point. So I guess I could have written any integral at all whose limits are 0 to pi over 2, and I would have gotten 1 point. But then to get both points, I basically have to have everything else. So 1 point for the limits, 1 point for everything else is how that works. And that was 2 points. So there's how they distributed the points on that one. So it's always a little bit of a guessing game to figure out how are they going to distribute the points and what kind of things are they going to give you points for. But as you go along paying attention to it, get an idea for what kinds of things they're looking for, what kinds of things they give you points for, and that can help guide you as you're trying to write your solution.